Hello, my name is Clem, and this video is a brief intro and demo of unit testing in Java. So what's unit testing? In Java, it basically means testing if your methods work as expected. So say you have a method called add that's expected to return the sum of its two parameters a and b. You'd simply be testing if it always returns the expected results, according to what parameters you give it. If you got what you expect, it passes the test. If not, it fails. So let's see this in code. Okay, so here's the add method in code, and what we'll be doing is using JUnit to make our tests for us. So JUnit is basically a framework that will provide all the methods and functions needed to run a unit test. So what you do is go to source packages, right-click, go to tools, and click create/update tests. Just click OK. And if it asks for JUnit 3 or 4, choose 4. So basically what it does is make this test class in a new test packages folder. And this test class comes with the methods you'll be using to run a unit test. So what you'll notice is you have these extra notations, these add before class, add after class, add before, and after. These notations determine when these methods will be run. So say you have an add before class, that means any method below it would be run before the class is constructed, and add after class, any method below it will be run after the class is torn down. There's add before, so this method will be run before each method. So unlike before class, this method will be run before every test. So yeah, this one before class, it only runs once. Before, it runs every time before a test, before every test basically. And after, it runs after every test. And this notation, this test, yes, basically divides each test into distinct units. So one test will be distinguished from another. So we'll just delete that because, to be honest, it doesn't really take that much code to test this. What you'll be using is the assert methods. Okay, so what these methods do is basically check if we got what we expect. So just type assert equals, we expect to get 4 if we add 2 and 2. Right click and click test file. And there, it shows we passed that one test, and you can go to output and see a summary of it. So one test run, no failures, no errors, no skips, and the time elapsed. Okay, so let's see what happens if we fail a test. So we'll go to our application logic and introduce this. Now right click and test file. So it shows that it failed the test, expected a 4, but instead got a 5. Okay, so what we have here is a more business-oriented example. What we'll be doing is a bit of test-driven development. What that means is we'll be making the tests first, and then we'll be coding. And what we'll be coding is this check password strength method that takes in a string and rates it from a scale of very weak to very strong. So if we go to the actual class, you'll see that we haven't actually implemented anything. And if we test it, it basically fails all of its tests. So let's do some coding so we can pass all of these tests. Okay, so I've made some code now, and just to put this into context, basically what it does is it adds points if your password has lowercase letters, uppercase letters, numbers, and special characters. And it basically deducts all points if it's an overused password. So if we run the test, we'll see that it still fails 2 tests. So let's just click this and we'll see which ones we failed. Okay, so we gave it a password 1, a string called password 1, and it's supposed to give back a very weak, but just gave back a weak. And we also failed this test. We gave it this very long password, but all we got was a strong instead of very strong. So we'll be making fixes to our code. So if the password length is greater than 20, we'll give it more points. So it should give back very strong this time. And see this time it passes. And now we'll add, what was it? Password 1 to the list of overused passwords. So with this code, it should give back very weak. And as you can see, we've passed all our tests. So we know this code works. So now we've seen what unit tests look like in code. But what makes a good unit test? Basically, they must be automated, repeatable, remain for later use, and run quickly. JUnit takes care of most of these, but you still have to ensure that tests can be run independently and do not rely on outside sources. What this means is you're basically just testing your class and nothing else. Not your database connection, not some code that some other vendor is making. And it doesn't matter what order you do the tests in. And that concludes the presentation. Thank you for listening.